Today we are covering the tangent line problem. This lesson may be covered in two parts as it is a little bit longer. Now a tangent line is a line that touches a graph only once near or at the given point. Similar to how it was in a circle, right? A tangent should only touch once at that point. So problems we're going to start with is approximate the slope of the graph at the specified points. Now, we've got an x is 1, so I filled in x is 1 right there, and we want to draw a line that kind of just touches at that point, and then check out the slope of that line. So my line, pretty close, kind of about just touches. So then you look, and what's the slope of this line? We'll go over 1, up 1.5. So should be about up 3 over 2. It's a little off from that. But maybe if we straighten it out, it might match a little bit closer. And yeah, it looks a little bit pretty close to that. Normally you try to find a nice point, right? Like here, it kind of looks like we touch, and then here's the next point that looks nice. So 1, 2, 1, 2, 3. So I would say 3/2 is a possible slope for that. Other people might find 2 because it does say approximate. I wouldn't expect a 1. It's more steep than a slope of 1. But anyways, that was about what I got. Next at x is 3, so that's the part of the graph we're looking at. So x is 3 way up here. It's kind of hard because the graph goes off, so then I'm going to kind of approximate it something like that. And then we're going to connect up. It looks like we connect about right here. Sorry, I'm using black again, but over 1, 1, 2, 3, 4, 5, 6. I got about a slope of 6, possibly even 7 because it's pretty steep. And again, it matches, so there's my answer, slope of 6. But again, maybe if you approximated, maybe you've got something slightly different. Maybe yours is closer to 5 or 5.5, and that's okay when the problem is approximate, right? Next, we've got one more set of these at x is 3. So again, x is 3, 1, 2, 3. This kind of looks like y equals x squared graph, and so got it labeled a little bit. It's a little bit hard because we continue, so I feel like that graph's pretty close, but I'm just going to extend it. And so, yeah, it's something like that, pretty close. 1, 2, 3, 4, 5, 6, 7. I got 7 or 8 here. It looks pretty close to 8. I may have only had 7 here, but again, because it's approximate and we're at the end of the graph, it can happen like that. Over here, it looks like I have minus 3/2. So as a reminder, like as we're going down here, slope should be negative at this point. And now that one's not a great tangent line because it looks like we connect here, and we do want to make sure it's only at the point. So adjusting it, looks like we go down 2 over 1. So I could see negative 3/2, negative 2. We're kind of in between the two with this picture. So again, with approximate, answers can vary a little bit there. Next, moving on, definition of slope of a graph. Clearly, slope is what our m value is. However, we're kind of talking about slope of a tangent line. The slope m of the graph of f at a point x, f of x, so xy, is equal to the slope of its tangent line at xy and is given by the limit as h goes to 0 of f of x plus h minus x all over h. And again, as a reminder, I did cover this in chapter 1, but this looks an awful lot like slope, and if we have the y value of f of x plus h, right, over the x value, right, x plus h, so y2 minus y1, y1's f of x over x2 minus x1, and then, oh, what do you know, the x's cancel here, and that's where this comes from. We're basically doing slope at a point. So going to the first problem, find the slope of the graph at the specified point. And again, you're doing this f of x plus h minus f of x all over h as h goes to 0. So this is not going away, has a lot of applications, continuing even further on into calculus. So don't feel like we're just kind of jumping through hoops here. This does have plenty of applications, also continues in physics and a little bit in computer science, I believe. So finding the slope of the graph of this, negative 4x plus 2 at 5 minus 18. Now we only really care about this x value. The y value just happens to be when you plug 5 in, what do we get? We got minus 18. So we're going to do f of x plus h, which is right here. We just put x plus h right here, minus 4 times x plus h plus 2, so minus 4x, minus 4h plus 2, and then we're subtracting the original, which is, again, minus a negative 4x plus 2, so double negative, so that cancels, so plus that 4x minus 4x, and a minus 2 plus 2 cancel, and typically you'll end up with only one piece that has h, pieces that have h left over. Dividing by h, negative 4h over h, and again, if you look at the question one more time, it seems odd, find the slope of the graph. I gave you mx plus b. If I told you find the slope of this, hopefully your question would have been minus 4 right away, right? Yep, and it should equal minus 4. So that's kind of why we're doing a cupcake one, because that's really easy. We didn't have to quadratic or FOIL anything. The h's cancel, and we get the limit as h goes to 0 of minus 4. There is no h, so it's just minus 4. Now, normally we have x left over when we do the difference quotient. When we have an x left over, you plug the x value of the point given back in, and we'll get a value. So you'll see that in the next example. F of x equals x squared plus 1, right? So now we're going to have a little bit of x left over. At 310, right? We're finding the slope of the graph at 310, algebraically. So f of x plus h minus f of x all over h of this. So x plus h squared plus 1, this is x plus h. Multiplying, we get x squared plus 2xh plus h squared. Plus 1 comes down, and now we're going to subtract the original. And yes, there's already some red marks here. Those are what cancels. Anything that doesn't have an h should cancel. X squared, cancel with minus x squared, plus 1, cancels with opposite of plus 1, which would be minus 1. And then we divide by h. So we'll have 2x plus h here, which is repeated down here. And then now that that is done, then we're doing the limit as h goes to 0. So this is 2x plus 0, which gives us 2x. And now the 310 comes back down here, and we're plugging in x is 3, so plug in 3 right here. The slope is 2 times 3, which is 6. So the slope of our tangent line is 6 at 310 of the graph x squared plus 1. Another one, f of x is the square root of 2x plus 3, and we're doing the point 11, 5. Again, x is 11 is a key point. So f of x plus h, and then minus f of x. We can't really simplify here. I did distribute the 2, and now we're going to multiply by the conjugate, right? To simplify this, we have a minus b. We need a plus b, which is square root of 2x plus 2h plus 3, plus the square root of 2x plus 3 over itself. And so this will join the bottom denominator, and these will clean each other out, right? And so we end up with everything under the square root comes out. 2x plus 2h plus 3 minus the quantity 2x plus 3. So 2x minus 2x, gone. 2h shouldn't be canceled out yet, but plus 3 minus 3 cancels. And then we're going to divide by h. Now we've got just these two pieces left. Again, it's a bit much, but just these two pieces are left. And the parentheses down here. So then when the h cancels, and we're going to have 2 over that radical. So now we're doing limit as h goes to 0 of 2 over square root of 2x plus 2h plus 3 plus square root of 2x plus 3. And what do you know? When you plug in 0, this becomes 2x plus 3 as well. Right? Like here. We lost the 2h because 2 times 0 is 0. 2x plus 0 plus 3 is 2x plus 3. And now we're going to have 2 over 2 of these, because we have 1, 2, and so the 2's cancel. We have 1 over 2x plus 3. Now, normally we would rationalize. Well, we got to plug x in, so let's plug x in and make sure it doesn't become a nice number. Now, x is 11, 3 for our y value, sorry, 5 for our y value. No y, so just plugging 2 times 11 is 22, plus 3 is 25. 1 over 25 is, square root of 25, pardon me, is 1/5. And so our answer is, slope is 1/5. Now that'll wrap up this portion of the video. In the next portion, we will get into, right, just think a second here. We have slope. What keeps us, this information right here, what keeps us from finding the whole equation of the tangent line at that point? Right? If you think about it, nothing. We could actually find the whole equation. What is the equation of the tangent line? That's coming next. If you have questions, please ask by email or in the Google Classroom. Thank you.